Hello everyone, this is Mrs. Lindsay, and today we're going to talk about the first derivative test. Let's start with a little bit of vocab here. So I'm going to go ahead and move this down just a little bit. Go ahead and pause the video and write these down. Some of these you might already know, but pause the video and write these down and then push play when you're done. Okay. So here we have relative max and mins. With these, we really only have the difference between the highest versus the lowest point here. So in this case here, the highest versus the lowest point of the function in the neighborhood near where you have an x value. So in these cases, we talk about relative max and mins. So here we'd have a relative min. Here we'd also have a relative min, where this point here would be a relative max. So again, this would be a relative max within this area of our function. This would be a relative min within the area of the function as well. However, we also have what we call absolute max and mins. This is the highest, and there's a mistake here. This should be lowest. I apologize for that. The highest and lowest point of the function ever. So when you're looking again at our graph here, the absolute min would be, let me switch colors here, this point over here, that is the absolute minimum or the lowest point of the function, of the entire function. In this case, we do not have an absolute max because it continues on indefinitely to infinity, and when you're talking about the highest point, so we do not have one. Extrema, what we call all the max and min points, okay? And the derivative, hopefully you remember this from our previous lessons, derivative of all extrema would be where we have a horizontal tangent, therefore is going to be 0, because again, if you look just here, here's our horizontal, oops, that's not very horizontal, but should be horizontal. That would have a slope of 0, so the derivative would be 0. So what's the connection between finding where a function is increasing and decreasing and identifying the relative extrema? So we'd found the function where it was increasing and decreasing the open intervals the previous day, but now we're jumping to the relative extrema, which is what we formally call the derivative test. Okay, so this is where we are switching from increasing to decreasing and vice versa. So the extrema, the relative extrema, max or min, again, where it switches from increasing to decreasing or decreasing to increasing on a function. Okay, and again, this is formally known as the derivative test. So, first derivative test, used to find and classify extrema, max and min. Also tells the intervals of increasing and decreasing, which is what we did the previous lesson, and now we're going to just extend it to finding the relative max and mins. This first derivative test, it finds the x value of your max or min. Okay, so then we will figure out how to find the y value as well. Okay, so let's scroll down just a little bit here. If f of x is continuous and differentiable on the interval a to b, then there exists a relative minimum if the derivative changes from decreasing to increasing. And then there's a relative maximum if the derivative changes from increasing to decreasing. So let's try a couple examples with this using the first derivative test. Find all the relative extrema of the function f of x equals 2x to the third minus 6x plus 1. So just like we were finding the open intervals, we're going to take the derivative of our function. So we'll get 6x squared minus 6. And again, we need to find where the derivative equals 0. And then we solve. So we can do this in a couple different fashions here. Add over 6, divide by 6, and then square root both sides. In this case, we cannot forget when we take the square root of 1, we'll have plus or minus 1. So just like what we did with our increasing and decreasing intervals, let's go ahead and put our critical numbers, which are 1 and negative 1, on that number line. And then we're going to pick values that are less than negative 1, in between negative 1, and above 1. So I'm going to, again, just pick negative 2, 0, and 2. And I would like you to pause the video here, substitute those in. Now please recall, though, we are plugging it into the derivative, not the original function. So we're plugging it into the derivative here to find those values. So go ahead and pause, calculate those, and figure out where it's increasing or decreasing. You don't need to write the intervals, just whether or not positive, negative in these open intervals. And you should have gotten 18, negative 6, and 18. So increasing, decreasing, increasing. Again, it doesn't necessarily matter what these values are. We just really care whether they're positive or negative. So if we go back to what we were talking about on the previous page here, relative minimum occur if the derivative changes from decreasing to increasing. So decreasing to increasing. So in this case, this would be a relative minimum here. But when I'm increasing, going to decreasing, that would be what we call a maximum. So our x values, so let me write these down here, our maximum would have an x value of negative 1, and our minimum would have an x value of 1. Now let's talk about how we actually come up with our y values. Anytime you're looking for your y value, you're going to use the original function. So to find our y value for our maximum, we're going to plug in f of negative 1 into our original function, and the same goes for the minimum. So we're going to plug those in. Okay, so in this case, if I plug in 1, I'll get 2 minus 6 plus 1, which is going to give us negative 3. And if I do the same for negative 1, this is going to be negative 2 plus 6 plus 1, which should give me a value of 5. So these are going to be our relative max and mins. Okay, so let's go ahead and move on to the next example. Here we're going to find the relative extrema of f of x equals the quantity x minus 3 raised to the 2/3. So go ahead, pause the video. Please find please find the derivative of this function, and when you're done, go ahead and push play to check your answer. Okay, so there's the derivative. Please realize that I did include the times 1. I'm going to go ahead and rewrite it again. The only reason I did that is because I want you to realize that this was chain rule. So the derivative of the inside function, x minus 3, is 1. Okay, but here's our derivative. But we might want to clean it up just a little bit. And what do I mean by that? Well, let's take this exponent. We'll use our 2/3 here. We're going to take our exponent. We have a negative, so that's going to bring it down to the denominator. But it's really the cube root. Oops. Of x minus 3. So to find our number line, we're going to set that equal to 0. which again in turn, if you recall, when we have a rate fraction, we really only need to set the numerator equal to 0 and the denominator equal to 0, because again we have undefined portions of our fraction here. This 0 equals 2 doesn't make sense, there's no x value there, but this is something over here that we can solve. So when we divide by 3, that just becomes 0. And then we will use a different color here, raise both sides to the power of 3, so that'll cancel there. And 0 cubed is just 0. So our critical number is x equals 3. Now we'll put that critical number, move up just a little bit so I can see my derivative. There it is, on the number line. And again, please pause this video. Check your values again in the open intervals below 3 and above 3, and determine whether or not x equals 3 is a relative minimum or maximum. When you're done, go ahead and push play to check your answers. Okay, so I got that it was decreasing below 3 and increasing above 3, therefore that would be a minimum. And then recall, so your x value is 3, and to recall to find your y value here, you got to use the original function. Original function, not derivative. Whenever you're finding the y value, use the original function. Substituted that back in and found my y value is 3. So we have a relative minimum at 3, 0. So this concludes the notes on the first derivative test.